Good afternoon, everyone. Thank you so much for joining us here for session number 5, Advancing Everglades Restoration. My name is Annalise Fussell. I'm with the Education Department here at Everglades Foundation. And today I have the pleasure of introducing to you guys one of our very own, someone with 25 years of Everglades science and teaching experience, including 10 years at the Texas A&M University teaching wetland ecology. And that special someone is our Everglades Foundation's Vice President of Communications and Engagement, as well as our Senior Ecologist, Dr. Steve Davis. Today, he'll be providing us with key information and any updates on Everglades restoration. And the goal for this session is to help you all have the knowledge to become expert communicators about Everglades restoration. And with that, I'll let you have the floor, Steve.
Great, thanks, Annalise. It's a pleasure to join you all this morning, and want to thank Jennifer for the opportunity to allow me to present to you and talk a little bit about the progress that we're making in Everglades restoration, but really to talk about kind of the underlying strategies, what Everglades restoration is about, and why we're doing this, what it focuses on in terms of these environmental resources that we value across South Florida. And it starts with the habitats. And I know that many of you are familiar with the different habitats across the Everglades. We've got sawgrass marshes, seagrass meadows in our coastal waters, tree islands, ridge and slough habitat. Near the coast, we have mangrove forests. We also have cypress forests, a number of different habitats that we associate with the Everglades. And one thing to keep in mind is that the plants that comprise these habitats, we find them really across a range of latitudes, from the tropics through the subtropics, and even up into the temperate regions. So this really interesting mix of habitats gives rise to the assemblage of animals that we find throughout the Everglades. So the different mammals and birds and fish species, reptilians, and the like, they are a direct result of this diverse mix of habitats that we associate with the Everglades. What also is a defining characteristic of this ecosystem is the patterns in rainfall. And many of you that live down here, you know this quite well. This is from a recent publication from one of our scientists on staff at the Everglades Foundation. And it just simply shows what many of you experience each year, is that much of our rainfall comes in the wet season. That coincides generally with the hurricane season. We get about 75% of our rainfall during this period of time. What that means is that the other half of the year, we only get about 20 to 25% of our rainfall. And it's getting the Everglades through that rather sometimes dark period that is what Everglades restoration is about, because that's when it suffers most, is during the dry season. And I'll talk about some examples of that. So to understand the changes that have taken place, we need to kind of go back in time. And if we had a satellite that could show us what the Everglades look like from above, south of Lake Okeechobee, it would look something like this: a connected ecosystem from the lake all the way down to and through Everglades National Park to the Florida Keys. And you can see that those different wetland habitats. At the southern rim of the lake, there was a pond apple forest or custard apple forest. Beyond that was a very dense sawgrass plain with very deep muck soils. Then there were ridges and sloughs and tree islands all the way down into what is now Everglades National Park, where Shark River Slough would funnel that water and through Taylor Slough down to the coast and into places like Florida Bay. The system is very different now. And these transformations, while they began in the late 1800s, they really hit their stride in the middle of the 20th century. And what resulted was a disconnection of the Everglades from Lake Okeechobee. Many of you know this already. That dense sawgrass plain became the Everglades agricultural area. Those deep muck soils were ideal for growing crops with our wonderful mild climate and rainfall patterns down here. Those areas just needed to be drained in order to access the soils. So what was left was about 50% of the Everglades, and in a highly compartmentalized state that, again, going back to the middle of the 20th century, was a system that was designed. This is really a designed ecosystem in the way it was drained and compartmentalized for agriculture. That was the big game in town back in the 1940s and 50s. And so this infrastructure that provided South Florida with flood control and to some extent water supply, to a great extent for agriculture being the focus, was an infrastructure that was designed for a population they didn't conceive exceeding 2 million people. And now we're in a situation where we have nearly 9 million people living in South Florida. So what we're left with is the Everglades as a water management system that retains some of the historic facets of the Everglades as it was in a pre-drainage form. Many of those habitats and species are still here. But we know that the system has been impacted over time by this flood control infrastructure, the thousands of miles of canals and levees and water structures, gates and pumps that move water from one area to another. It doesn't flow like a river of grass anymore. But we also know that we have very important areas in South Florida. We have national parks, large areas of protected lands within these national parks, the water conservation areas, state protected areas, national wildlife refuges. And we also know that we have nearly 80 threatened or endangered species that depend on different areas of this ecosystem. So getting the water right is imperative to protecting these places and these species. Now, if we could lump our problems into a couple of bins, it would be either in the water quality bin or the water quantity bin for the most part. And many of you are familiar with Lake Okeechobee. This is a polluted water body. It's really the giant reservoir of water within South Florida, and I'll talk a little bit more about that later. But it's managed as a reservoir today. It fills up. That water has to be sent to the east and the west because it's polluted. It often carries high pollutant loads and toxic algae with it. That water discharged to both coasts causes problems there as well that are primarily, both water quality and quantity related because those discharges are such high in volume. Further south in the Everglades, because that water doesn't flow south anymore, and in the dry season, we just experienced this a few months ago. Many of you probably saw we had fires across much of the Everglades. Those areas dry out and they burn readily when we get a little bit of lightning. That area is also the primary water supply for the lower East Coast. So you think communities from the Florida Keys all the way up to southern Palm Beach County derive their water supply from this area. So because water isn't going south, that is a problem. In Florida Bay, at the southern tip, because we're not getting enough fresh water down there, particularly in dry seasons, the salinity can get to excess levels to the point where we see seagrass die-off and habitat problems down there. Likewise, because we don't have enough fresh water flowing south, as we get into the late dry season months of April and May, we see the impacts of saltwater intrusion from sea level rise affecting a larger area of our coastal Everglades. So I'll talk a little bit about the impacts of each of these. In the Everglades, the water quantity issues can be summarized almost like the Goldilocks and Three Bears story. If we go into Water Conservation Area 3, that's the largest of the water conservation areas between Tamiami Trail, going up past Alligator Alley, up into the edge of the Everglades agricultural area. If you're in middle Water Conservation Area 3A, you see ideal Everglades habitat. This is what All of our evidence suggests the historic Everglades and ridge and slough habitat looked like. This is an aerial photo from above. You can see that it's got those nice striations, tree islands, sawgrass ridges and sloughs, and it's that corrugated topography that really typifies the Everglades. And you can see how that diverse habitat structure gives rise to habitat for wading birds, fish, mammals, etc. In upper Water Conservation Area 3, areas that are slightly higher in elevation, this will be just north of Alligator Alley. This area is dry too frequently and for too long. And so we've seen that corrugation across the habitat disappearing. Those muck soils are flattening out and we're losing the sloughs. So if you were to look at that habitat from above, you can see there's not a lot of standing water. In fact, you can see a burn scar here. That transition is the result of a past burn. And these areas do burn quite frequently and severely because they're marshes that are no longer wet. At the southernmost end of Water Conservation Area 3, and there's about a 4-foot elevation change from top to bottom. This is where the water piles up against those levees and roads like Tamami Trail. And this area has a fairly well-preserved corrugated habitat. You can see the remnants of the tree island and the sawgrass ridge peats in these areas, but the water is just too deep to support that vegetation. In fact, some of the tree islands are transforming into what scientists call ghost islands because you can still see the footprint of the tree island there, but they don't support the trees as they did historically. So this is what those areas look like. And as we restore the flow of water south and open up those barriers to flow, we can equalize the water levels and help restore these habitats. So that's important to think about what restoration achieves. And those habitats are critically important for driving the ecological function of the Everglades. And when I describe the functionality of the Everglades, one of the things that I talk about most often is that it's a massive food concentrator. And by that, I mean that when you have these ridges of sawgrass and sloughs, when water levels are high, you get a large area producing fish and invertebrates. As the dry season progresses, all those fish and aquatic bugs concentrate into pools. And it's that concentration that is what triggers the nesting of wading birds across the Everglades. And it's really what allows a low nutrient environment like the Everglades to be highly productive in terms of fish and upper trophic levels like wading birds and alligators. So this is one of the functional attributes that we try to restore in the Everglades. If we were to zoom in on this, over time, you would see that water levels recede, more diverse birds start to show up, shorter legs, longer legs, and they occupy different areas as the fish concentrate across these deeper sloughs throughout the dry season. And the longer that concentration can occur, the more successful we have with our nesting and fledging of those young and recruitment into the population. Unfortunately, too many areas of the Everglades, as I showed you, are either too dry and certainly aren't going to support fish, or they're too deep and you don't have that essential concentration to provide for the needs of both the adults, the parents, as well as the chicks that are waiting for some food to come back to the nest. Likewise, we run into some problems where water levels change too rapidly in this current managed Everglades. Again, because there are compartments, and usually when our wet season hits, it hits all at once, water levels can shoot up pretty quickly. When you add in the fact that there's a massive purging of water through flood control into the Everglades, that really accelerates the water level rise. And that was a situation that we saw this past May. And all evidence suggests that as a result of that water level reversal, the extremeness of it it resulted in failed wading bird nesting across much of the Everglades. Now, thinking about water quantity further south, I talked about sea level rise and the impacts that it can have. And without fresh water flowing through the Everglades, we have a reduced pressure against sea level rise that encroaches ever landward. And some colleagues of mine and I, we have been working on this as a scientific agenda for nearly a decade now, and National Geographic picked up on it. This was an issue back in 2016 where they focused on climate change impacts on our national parks. And we have shown over time that with sea level rise and saltwater intrusion into the Everglades, especially when we have a reduced freshwater flow, that results in the dieback of sawgrass marshes and ultimately leads to the breakdown of those soils to the point where we have open holes across much of the landscape. And I'll show you a few pictures of this. The bottom picture is an up-close image of an area of sawgrass peat collapse. And you can see that the soils are actually dropping around these plants. In some cases, the roots of the plants are exposed to the air. If you look at it from above, this is from an airplane up here in the upper right, it looks like Swiss cheese across the landscape. And it's important to recognize this as a problem in the coastal Everglades, because as this is occurring, these areas are now too deep for the mangroves, which are encroaching around this remnant sawgrass patch close to the coast. These areas are now too deep for mangroves to become established and stabilize those soils. So what this results in through the future, as we move forward, more of an open, unprotected shoreline of South Florida, and certainly less habitat value than something that mangroves would provide. Now, I've talked primarily about water quantity. There's also the water quality issue. Phosphorus pollution is our major problem. As our native marshes become exposed to phosphorus in excess of 10 parts per billion, over time we see a transformation to nothing but cattail. And our most recent cattail map, unfortunately, is about 16 years old now. The Water Management District last did this in 2004, and they showed that what we have effectively is nearly 100,000 acres of the water conservation areas that at that time were polluted with phosphorus and converting to cattail. The solution to this, as many of you know, is the construction of stormwater treatment areas. These areas in blue are primarily water treatment features that the state and to some extent the Corps of Engineers have built to clean up the water coming off that agricultural area south of the lake. It's important to know that water doesn't flow directly from Lake Okeechobee into the Everglades. What the Everglades gets is the runoff from these primarily sugar fields that add more fertilizer. That water has to be cleansed through these filtration marshes so that we're not continuing to pollute the Everglades and see further expansion of cattail across the ecosystem. What Everglades restoration does, it taps into the lake through the construction of storage and allows us to move more water to the south. And I'll also talk about a strategy that we're also pursuing of just even before the reservoir is built, begin that process of moving lake water to the south, especially during that dry season when it's needed most. Well, I don't need to go into the comprehensive Everglades restoration plan. You all are familiar with that. These are largely projects that help to restore the quantity and quality of water, the timing of that water. We know the dry season is important, and sending it south. And part of that is not just the infrastructure, but also the operations of that infrastructure, the rules by which we can move water from one area to another, and again, trying to mimic that natural pattern. Now, we have some model or simulation data that compares the current Everglades to what the historic Everglades looked like in terms of just monthly flows. And this is at Shark River Slough in Everglades National Park. So if you imagine just south of Tamiami Trail there, not too far from Shark Valley, this is what the Everglades looked like in terms of flows throughout the year. The blue area I've shaded is typically our wet season. The reddish area is typically our dry season. You can see the pre-drainage Everglades, these blue and purple lines, were much wetter, not only in the wet season, but also in the dry season. That's important to point out. The current system is incredibly dry during the dry season. Sometimes it dries out completely, and it only is fed by rainfall and a little bit of runoff during the wet season. So as we restore, we get not only higher peaks in the wet season, but we also hydrate the Everglades more so in the dry season. Now, these values are in thousands of acre feet, and 1 acre foot is 326,000 gallons of water. So we're talking massive quantities of water that would go south. And in terms of sending water south, we have to go back to Lake Okeechobee, because this is really the elephant in the room. This is our massive storage of water in South Florida. This 720 square mile lake, surrounded by the Herbert Hoover Dike. Many of you know that. It's not entirely an open water lake. It has some marsh and near shore habitats, but the lake is a massive water body. And to put its volume into perspective, about 1 inch of a rise in water is, give or take, about 10 billion gallons of water. So for every inch the lake goes up or down, just think in terms of those quantities. So when we're talking about sending water south, there's a lot of volume to speak of here in Lake Okeechobee. Not just that, but also the discharges. And one of the things that water managers pay closest attention to with Lake Okeechobee are the lake levels. And the lake levels over the past year and a half are shown in blue on this chart. These blue lines are relative to this black line here, which is what the water managers call the water shortage zone. And then this top line is the high lake management zone. Now, keeping in mind that the lake is surrounded by a dike, that it fills up much faster than we can get water out of it, and the primary outflows from the lake are to the east and the west, the idea is to try to minimize those harmful discharges as much as possible. That's become more of the mindset of the Corps of Engineers, especially these last couple of years, where the lake has been managed at lower levels to try to minimize risk of discharge. But you can see that the lake can shoot up pretty quickly over a relatively short period of time. And again, recall back to that notion that about 1 inch is 10 billion or so gallons of water. We're talking about a lot of water. And so the discharges that are made to the east and west, oftentimes they're anticipatory. And so having a new outlet, a strategy to send water south, not just through infrastructure, but through the operations, provides water managers really with another tool in the tool set to manage water and potentially reduce the risk of those harmful discharges. Now, these past couple of months are probably the best example of how the system's managed. Go back to April. We were pretty dry in the month of March, record low rainfall in March. We were in a relatively mild drought. And you can see from this map that the system is really being operated as it was designed to suit the needs of agriculture. Even though South Florida has changed rather dramatically, we're now near 9 million. Much of our economy is driven by tourism and real estate. And we have this dense populated area along the lower East Coast that depends on the Everglades for their water supply. Yet look, on this particular day, April 15th, who was getting all the water? This is 4 billion gallons of water in one day, nearly a half an inch off Lake Okeechobee going to this agricultural area. All these zeros should shock you. That means there's no water flowing through the River of Grass. Everglades National Park, Big Cypress National Preserve was on fire, and Florida Bay was hypersaline, nearly 50% higher salinity than ocean water. Now, when the rainy season hit, many of you recall we had about 10 inches or so the last 2 weeks of May. Look how things changed. They no longer want the water because it's been raining. So they go into flood protection mode. They pull zero water out of the lake, and they're filling up all those stormwater treatment areas to clean the water so we can move it through the Everglades. Unfortunately, there's just not enough conveyance capacity to move those quantities of water that we get from the rainfall, as well as all that flood control water. And we see the impacts on the ecology of the system with very rapid water level rises. And I described the scenario of the impacts to wading birds, but you can also see, look at this high volume of flow coming into Lake Okeechobee in early June. So that just speaks to the yo-yo effect of how this water management system works and the impacts that it has across the ecosystem. Now, many of you are familiar with the Everglades Reservoir. That's infrastructure, big infrastructure that helps us move large quantities of water from Lake Okeechobee, where we clean that water and flow it south. It also cuts those discharges to the east and west by upwards of 55%. This is a massive amount of water, 120 billion gallons of water that this reservoir will move south on average. And as we move that water south, we use the conveyance provided by the bridges of Tamiami Trail, the other projects that will result in backfilling of canals to move that water as a river of grass once did, get that water down to Everglades National Park and ultimately into Florida Bay. We know these projects work. The Kissimmee River Restoration Project is probably our best guide. An example of that, the red line on this is where the canal was dredged to get water into Lake Okeechobee faster. You can see that that meandering river with its sandbars has completely found its old channel. We've seen improvements in water quality, waterfowl, fisheries as a result of that project. So we know these large-scale projects deliver benefits. We also know economically they make sense. This is an economic study that was done 10 years ago, but it's still relevant today because it showed that Everglades restoration delivers huge benefits. 4-to-1 return on investment in sectors of water quality, real estate, fishing, all the recreational amenities that you would associate with these places in South Florida, including our coastal waters. And speaking of our coastal waters, it's about getting water back through the Everglades, ultimately down to Florida Bay. This is the finish line. And I include this image because the brown water is not polluted. That's tannin colored water that has passed through the mangroves there in Lower Taylor Slough. This is a natural phenomenon, but I think it's a great qualitative indicator of our goal, and that's getting water south. So that's all I have, and I'm happy to take any questions.
Thank you, Steve. That was incredible. I know just from our own team's perspective, we learned a lot about Everglades restoration and what's going on. The chat has been really great. People have been loving the visuals and really great explanations. So if you're ready, I think we are ready to start answering questions. I do want to address a question right at the beginning. Let's see here. So one question we had, I heard that Florida government, South Florida Water Management District, and the U.S. Army Corps of Engineers do not support the restoration plan with fidelity. Is this true?
With fidelity, that's difficult to interpret. They are a partner in Everglades restoration. They are the recipient of funding from the state of Florida to build these projects that are in the plan. So I think that there have been some governing boards that haven't been as committed to building the critical projects that are needed sooner than later, the Everglades Reservoir being probably the best example. But I think there's been a commitment to restoration all along. It's just that now we have a governing board that is not only recognizing the importance of this, but they're doing the heavy lifting needed to get these projects like the Everglades Reservoir built. So we're seeing the result of momentum that we've gained over the last decade. And it's really come at the right time with a governor who's made this a priority for his administration.
Wonderful. That was a really great answer. Thank you. Another great question is about the unique topography of the Everglades. So why and how do tree islands form, and how come sediment accumulates like that? What drives it?
Wow, that's probably a question for my wife, who's the tree island expert in the family. But it's the gradual sheet flow of water through the Everglades that drives the processes that lead to this corrugation across the landscape. And it was the sort of epic pulses of water that would move through the river of grass that would carve out those sloughs, deposit sediment almost like a floodplain onto those sawgrass ridges. And the plants themselves help to sustain that offset of elevation over time. The tree islands are kind of a unique situation because some of them have been shown to form through a variety of processes, but the vegetation is an important part of that process. In the case of tree islands, though, it appears that the fact that they move so much water from the ground to the atmosphere is part of that process and leads to the formation of mineral rock development within the cores of those tree islands, especially at the higher elevations. So it's a really interesting process, but suffice it to say that the vegetation and the flows play a big part in that.
That's awesome. That's really interesting. I really like this question, and it's not something that I've ever thought of. Given that the flow has been changed for such a long time, is there any biological or environmental disadvantages that might have come up about restoring the flow to its original state?
Well, that's a great question. And so some of these areas where we have lost that patterned landscape of higher elevation ridges and tree islands, lower elevation sloughs, and the landscape has flattened, what that might mean is those areas are no longer going to be places of food concentration. They're effectively not now, but it just might mean that they're deeper areas of marsh than what you would find, say, further to the south in Water Conservation Area 3. So there will be some ecological implications, and I don't necessarily think that's a bad thing. It might just be areas where you might get more largemouth bass growing, or more ideal habitat for soft-shell turtles, or something like that. And then you have more of a functioning ridge and slough habitat to the south where that food concentration would be maintained. But scientists are also asking questions about how we might be able to jumpstart that process of ridge and slough formation. It takes centuries for it to develop naturally, but we're trying to understand if we can jumpstart that in a way where it would only take maybe decades to get it back.
Right. That makes a lot of sense. And of course, everything has a consequences. So that's really interesting to hear. Another great question, would building water treatment plants on the east and west of Lake Okeechobee solve the problem of toxicity in the Gulf and the ocean?
That's also being addressed in part. So those discharges from the lake to the east and the west, they're of such large volume that we simply can't treat them. And even if we could draw upon the capacity of all those 50 to 60,000 stormwater treatment areas to the south, it's still not enough to treat those large volumes of water going east and west. And in fact, Everglades restoration fully built out doesn't eliminate all the discharges. So this is going to be a problem that we have to continue to deal with. Building stormwater treatment areas for the reservoirs along the east and west coast will solve some of the problem, not all of it. Cleaning up flows into Lake Okeechobee will solve some of the problem, not all of it. We also have decades of pollution within the lake that needs to be addressed. Our solution of sending water south as much as we can really cuts into a lot of that problem, because if you can send it south, we know that water has to be clean before it goes into the Everglades. You reduce those discharges, and so you're not polluting.
Yeah, absolutely. Those are great answers. I mean, Everglades restoration is really never over. You know, we're always trying to clean and restore. We'll end on one question that everyone is dying to know. Where are we with the construction of the new EAA reservoir? How's that looking?
It's so exciting, because we're talking about a project that's 20 years in the making. It was authorized right out of the box in 2000 when SERP was passed, and for a variety of reasons, mostly political reasons, we have not made much progress. But the Water Management District in April began turning dirt on the stormwater treatment area associated with that reservoir. And the Everglades Foundation is doing all we can to undo a designation for the reservoir project as being a new start. Again, I just referenced we've been at this for 20 years, and the Corps of Engineers said it was a new start recently, and so that would delay their end of the construction part of that reservoir. So we're hoping that, combined with what the district's doing and our policy and advocacy work, we can get this project built in 5 to 8 years.
That's fantastic. I know a lot of people are really excited about that. I know at the foundation, we're super excited about that. And we're really happy that, you know, things are moving along. So with that, just thank you all so much for joining us today. Thank you, Steve. You're a world of information, and I know that we threw some tough questions at you, but it's always great to see where we're at with Everglades restoration, and as well as just kind of giving teachers that background information that they can take Everglades knowledge into their schools to teach the students about the Everglades, whether it is just about plants, animals, and habitats, or whether it is about big topics like restoration. So we're really happy that we have that foundation of science. So thank you. All of our teachers that are attending, if you haven't done so already, our last session, I know, I can't believe it, is next. It's the neuroscience of stress, the reciprocity of well-being, with Chi Kim at 2:50. So after a nice day, you can de-stress, join us. We'll do some fun breathing techniques and kind of look at what the next year looks like. So thank you all so much for attending. Let us know if you have questions, and we'll continue to update our website with the information about this session. So thank you, guys. Thanks, Steve.